Hi everyone, welcome back to my channel. Today, I'm sharing my reflection on something that powers almost all the technology we use, chips. I watched several videos about chip manufacturing. Why chip making is so difficult, photolithography, how CPUs are made, and the future trends in computer engineering. As future engineers, we need to understand how these tiny pieces of silicon basically run the world and how they'll shape our future. So, let's dive in. So, the first video is about, we talk about in the first video is, the first thing that shocked me is how complex chip manufacturing really is. We start with silicon, purified, melted, and grown into a perfect crystal. Then it's sliced into wafers, polished until flawless. Chips requires dozens of steps, like for example is um, deposition, etching, like doping, layering, and every step must be done in an ultra clean room. Every one speck of dust, even one speck of dust can destroy a chip. Fabs cost billions of dollars. The technology, the machines, the clean rooms, everything is incredibly expensive. And this made me realize chip manufacturing isn't just engineering. It's engineering at the absolute limits of physics and materials. So the next uh, the next video is about the second video is about they explained why chip making is so hard. And honestly, I didn't realize how brutal the process is. So the reason why, extreme precision. Transistors are now around 3 to 7 nanometers. That is smaller than a virus. One misalignment, chip, ruined. So the number 2 is purity. Materials must be 99.9199% pure. Any contamination kills the chip. Reason 3. Global supply chain. Hundreds of companies supply chemicals, tools, gases, components. One delay can affect production. So the reason number 4, huge risks and cost. You invest billions, but a single defect can ruin an entire wafer, right? For me, seeing how fragile and precise the process gave me a new respect for the devices we use daily. These chips did not come easy, right? What do you think about that, guys? So, in the next video, we talk about the photolithography. So, this is the most fascinating part for me. Why? So, imagine trying to print a microscopic CP onto silicon using light. That's basically lithography. A photomask is created like a circuit stance. Light shines through the mask onto the water. The pattern transfers and then the wafer is etched. So this is done layer after layer and after layer. Modern chips have dozens of layers, stacked like microscopic skyscrapers. And because these features are so tiny, companies now use EUV, extreme ultraviolet light. The machines for this cost around $150 million each. Watching photolithography made me realize chip making is not just manufacturing. It's physics, optics, chemistry, engineering, all happening at once. So, so the next video or the next that we watch is about on how CPUs are made. Put everything into perspective. After lithography and processing, the wafer is cut into tiny squares called dies. Each die is tested. Many are defective and thrown away. Only the perfect ones survive. The working dies are then packaged. The working dies are packaged. So, connected with gold or copper wires, mounted into a chip housing, and then protected by epoxy or metal, and then labeled and tested it again. It's crazy how something so small, the size of a fingernail, can have billions of transistors. And now when I look at a CPU, I see more than a component. I see thousands of engineers, years of research, billions of dollars, and then breathtaking precisions, all inside one tiny square. So the next is to talk about the future. Let's talk about the future, because everything we just learned about chip connects to what's coming next. So future trend number 1, all AI everywhere. AI is exploding. We need specialized chips, AI accelerators, neuromorphic chips, ML processors. 2. Autonomous vehicles. Self-driving cars require powerful chips that can process camera, radar, LiDAR data. Number 3 is IoT and edge computing. Billions of devices. From fridges to streetlights, we need efficient chips. 4 is quantum, less classical hybrid. So, quantum processors won't replace CPUs, but they will work with them. 5 is green and sustainable computing. Chips must become more power efficient. Data centers consume massive amounts of energy, like that. So number 6, chiplets and 3D stacking. Instead of shrinking transistors forever, companies are now stacking chips like Lego. 7. AI-assisted chip design. AI will help design the next generation of microchips. Number 8. Cybersecurity hardware. Security will be built into the silicon itself. Number 9. Digital twins. Entire factories, cities, and machines will have virtual chip-powered twins. 10. New materials. GaN, CC, and graphene will lead new innovations, especially in electric vehicles and solar tech. So that is all about the video. So all these trends remind me that the future of computer engineering will not just be about coding. It will be about understanding hardware systems sustainability, and global impact. Right? So the next is 8. After watching all the videos, here are my reflections as a future engineer. I realized that behind every devices I take for granted, my phone, my laptop, there are decades of innovation and unimaginable precisions. Chips manufacturing taught me patience. Photolithography taught me the beauty of engineering. Um, CPU production taught me respect for hardware. And future tech trends taught me responsibility. As future engineers, we must think about sustainability, push innovations, understand both hardware and software, and build technology that benefits people. Chip making is more than science. It's humanity's attempt to control atoms to create intelligence. So, so yes, intelligence, okay? So, that is my reflection on chip manufacturing and the future of computer engineering. I hope this helped you appreciate how incredible this field is and how important our roles will be in shaping the future. If you enjoyed this reflection, don't forget to like, comment, and subscribe. Thanks for watching and see you in the next video. Bye bye.